Hello guys, let's consider questions associated with forces and motion. Okay, let's consider this first question here, which says a box being pulled across the rough floor at an angle that is 20 degrees above horizontal. So we need to draw here a force diagram. Okay, so we need to draw a force diagram here. So rough surface means there is a frictional force. Okay. So as you can see, we have applied force acting 20 degrees above horizontal, frictional force opposing the motion. Then we have weight acting downwards and the normal force acting downwards. Or you can represent the object with a dot. So we have applied force acting. You can even write letter F there. Like it is acting 20 degrees above horizontal and friction opposing the motion. Then we have the weight acting downwards and the normal force acting upwards. Okay, so we can even use symbols to to label this. Okay, let's check the next question. A man pushes a car with a force of 400 newtons. Coefficient of kinetic friction is 0.2. Coefficient of kinetic friction is 0.2. Okay. So, and the mass of the car is 2,600 kg. We need to calculate the acceleration of the car. Okay. As you can see here, we have a car, so which is being pushed 400 newtons. Okay, so which means we also have a friction here opposing a motion. So we have the normal force acting up and the weight of the car acting downwards. So we know that the sum of forces acting according to Newton's second law is equal to ma. Okay. So we're looking for the mass. Let's check the forces acting. We have an applied force minus friction, which is equal to ma. So let's check what is the friction. We're given the coefficient of friction. We know that kinetic friction is the same as the coefficient of kinetic friction times the normal force. Times the normal force. So, and the normal force here in this case is the same as the normal force in this case is the same as mg, as the mass. So mass times g. Okay, so we can substitute it there and make A the subject of the formula. So we are going to have F applied force. You can even write it as FA and minus kinetic friction, which is coefficient of kinetic friction times mg. Okay, so all over m. Let's substitute. Applied force is 400. So minus coefficient of kinetic friction is 0.2. Times 2,600. Okay, all over. Oh, sorry, it's mg times 9.6. all over 2,600. Let's work it out. So 400 and 0.2 times 2, 600 times 9.8 all over 266. Okay, the answer is 1.8. Okay, the answer is negative 1.8 meters per second squared. It shows that it will move opposite, so which means that applied force is not here. It's not enough to push this car. Okay, 7.3 says the figure below shows an acceleration versus force graph for 500 grams. So what acceleration values go in the blank on the vertical scale? Okay, so you can see here we have A, here we have B, that is acceleration. Okay, so the mass of the object is 500 grams. We divide it by 1,000, we get 0.5 and 0.5 kg. Okay, so now let's check here. And A correspond with 2. So when F, okay, let's work it out here. When F is equal to 2, equal to 2 newtons, okay, we apply Newton's second law, which says the sum of F is equal to MA. Okay, the sum of F is equal to MA. All right. So we have the only one force that is acting there. So which means when F is equal to 2, so okay, let's make A the subject of the formula here. So we have A, which is equal to the sum of F all over M. Okay. So let's check now. When F is 2, we have 2 over 0.5. So 2 divided by 0.5. So which means acceleration will be 4 meters per second squared. Okay. So remember A is directly proportional to the force. Let's check now. Okay. B here correspond with F equal to 1. So you can say here when F is equal to 2 newtons. F is equal to 1 newtons. Okay, let's check what is A. So A is equal to 1 divided by 0.5, which is 2 newtons. Okay, those are the answers for A at A and A at B. Okay, let's check the next question. The 2.0 kg wood box shown in the figure below slides down a vertical wood wall while you push on it at a 45 degrees angle. Okay, so this is at a 45 degrees angle. So what magnitude of force should you apply to cause the box to slide down? Okay, so we're applying a force in this direction. Okay, so let's say this is the box. So here is applied force. Let's call it F. And so there's gravity, of course, acting vertical downwards. Let's write it as mg. Okay, let's check. There is a normal force, which is always acting perpendicular to the surface. That is the normal force. Okay, let's check. There is also a frictional force, because the motion is downwards, so frictional force will be in this direction. Let's write small letter f for frictional force. Okay. That is our free body diagram. Okay. So let's check it. This is it's 45 to the horizontal, so it's also 45 to the vertical. Okay. So now let's work it out. The question is, what magnitude of force should you apply to cause the box to slide down at a constant speed? All right, so let's see. With this applied force here, frictional force, this is 45. Then we have mg, and we have a normal force. Okay, so if we resolve this force here, we're going to have F cos 45 degrees. Okay, so now sum of F according to Newton's second law is equal to ma. But if the block is sliding at constant speed, then acceleration is 0. Okay, let's take up as positive. So we're going to have F applied force cos 45 minus the frictional force. So okay, frictional force is also upwards, so it's plus the frictional force, then minus mg equal to 0. So we're looking for F, we make F the subject of the formula. If we take everything to that other side, so the sign is going to change, minus F all over cos 45. Okay. So let's check our given. Let's check what is given there. What is given? The 2,0 kg wood box shown in the figure below slides it down. Okay. So friction is not given. Okay. No, it's fine. Okay, let's just substitute what is given. The mass is given. 2,0 kg times g is 9,8 meters per second squared minus friction. Okay, friction coefficient it's not given there, so we just leave this as friction. Okay, so this side minus friction all over cos 45. Okay, so if the frictional force was given here, so then we know the frictional force is also equal the component of the force. So what we're going to do, we're going to resolve this and get F sine 45. Then we're going to have frictional force, which is mu, times the normal force. Then you're going to say the normal force is equal to F. Okay, let's see. We're going to say here the normal force balances, and F is equal to F sine 45 degrees. Then and substitute it again where there is a frictional force. Okay, let's go back to the solutions. And then let's go back to the questions. Okay, guys, the rest of the questions is these activities. So please make sure that you do them by yourself. Okay. Okay, thank you guys. Okay, thank you, bye-bye.